Good afternoon. I will introduce you this video. There is a collaboration between the SysML approach about natural ventilation and our approach from parametric modeling using the tool like Rhino-Zeros and Grasshopper as a parametric. Index of diagrams that we use, and this is the SysML environment. And our first approach has been to develop this kind of interoperability experience between SysML and different applications that we use in our domain of architecture, as is the case of Rhino-Zeros and Grasshopper. You can see here what is our idea about the diagram of the application involved in this process. So we have two approaches. I'm working now in the architect approach that uses Rhino at the early stages of design plus Grasshopper to generate easily different and several versions of a project, building a part, whatever it is. And on the other hand, I'm going to introduce the SysML2 and recreate some equations to calculate natural ventilation in early stages of design using this input of this Excel in to Model Center. So basically this Excel file with information is going to feed the Grasshopper definition and also this SysML to Model Center. So every change that we make in this Excel is going to be represented in parallel situations. Let me say, situation 1 is that what is going on with the model. Situation 2 is what is going on with the calculations and the results that we can do kind of the optimization process based on our results and based on what we get as a geometry of our project. So we have here this is an explanation of our process, and so our idea is generating these parametric iterations on design process to see how our decisions in science are going to affect the appearance of our building. This is our main goal. So, and for that, we have, this is the diagram of the packages of our SysML. So I will show you here. This is our parametric design phase. So here we have the architect feeding some Excel and getting almost in real time feedback of this iteration between Grasshopper and Rhino. The first step, what I'm showing you is SysML files, because the first step that we create is the definition of the elements of the parts that are going to be in our model. So we can see here we have this natural ventilated building that got like stock. There is like an empty space in the middle of the building, the weather, terrain, and here is how we recreate the building as an understanding that is built from different entities. So we have a building story. This would be our basic units that we got a roof, subspace, and air. And also this subspace got the walls that could be for multiplicity, 1, 2, many. And each wall could be exterior stock and interior wall, and they have a door and windows. So let's go to the Rhino environment. So what we have here is what I've been doing in our parametric design and scripting class, and this is the definition in Grasshopper that comes from this diagram that I was showing to you. So all those entities are created here in a parametric way, and getting the data from Excel. So for example, we can go beside having all the geometry of the building here, the points of the base, the height, the extrusions of the wall, the offsets of the thickness of the wall, or everything else. So we also have created those, for example, let me show you these sources, and that are definitions of scripting, Visual Basic scripting in Grasshopper. So you can see here what I did here is creating this code to call data from the different cells and rows of my Excel file. So that's the idea of this. It's creating this hyper, it's not hyper, but it's real-time updating of this model using this tool. And so what we have here is, you can see, I will show you now, we have an Excel file here, and we have this Grasshopper definition. You can see that this is red. So what happened is that this definition is created using this data that is going to feed my Grasshopper definition. And as you can see here, we are going to make a change that you can realize where is the idea of this. For example, we are going to change the number of building stories to 10. We are going to change also the size of the height of the windows to 14. And we can also make some change in the, for example, we're going to change this dimension of the base of the building. So what happened now is that we are going to recompute this definition in Grasshopper. Let's see if it's working. Yeah, it's working. So in this, it's going to take like some seconds, and what's going to happen is we are going to update using this data the building, as you can see here. So now we have a kind of a different building. So, and this data you see here is also updating all the information about areas that we are taking from the model. And with that information, we get all the data necessary for developing our calculations in SysML. So what happened in SysML, we have these, for example, this is an internal block definition that we generate all the semantics and the relationship between different the parts of our building. This is a story. You can see this is the story. The story got 4 subspaces and we're stuck in the middle, and it's the showing the relationship between the exterior windows and what happened with the air flowing into the spaces. So this is more or less the schema of what's going on. So that's where we're creating in our definition in Grasshopper. And this is we have here. If you can see here, we have the four spaces, the windows, exterior windows, as in the SysML model. So, and in the SysML model also, we can go. We're going to do this. This is our analysis process that we have. This the Excel that we are creating, and we're using with the Grasshopper definition, and we generate this parametric diagram to model the center and to create an instance of that using the data for the Excel. And that's the same that we have here in our model. This is the instance that we are surveying in this process. And using those equations, we can calculate, and those difference approach of the location of the window, we can calculate how good or how bad is our lateral ventilation, or how much time is going to take to recreate that. And we can see, for example, this is model center 1. So, and what I did is creating 3 instances using just 5 stories building, you can see here, and using this model center approach, we generate all the results about lateral ventilation in our buildings. This is the best one. I'm not going to explain that now, but you can see here in the graphic. This is even if we still have some situation got some trouble. This is the best behavior about lateral ventilation. This is the one that got the biggest windows, and this is the data, the result of that. So I think that's more or less what I've been doing here with this Grasshopper definition. And the last thing that I will show you is when you, at the end, when you are fine with your data that you obtain for the SysML process, we bake that as we have 2 kind of, I'm going to bake in 2 ways. Showing you when you have an instance of your building, and use all the structural elements and the stack, some rails inside, windows, and SysML develop this data and the result of the analysis, so you can compare what is the design doing with your calculations, so that you can improve both sides of the design, the performance for one side and the appearance for the other side too. Alright. And we can, with that approach, we can easily produce several options of our building in just a few minutes, and they were going to have all the calculations about lateral ventilation in the early stages of design. Okay. Thank you very much.